Okay, hello, my name is Richard Singer, and I am the teacher here at St. Louis YouthBuild. St. Louis, the garden spot of the Midwest. You know, the Arch, gateway to the West, we have the St. Louis Cardinals, we've got the St. Louis Blues, and we got a football team too. Anyway, I am the teacher here, and I'm also happy to be the teacher here because St. Louis YouthBuild has done really a lot of good for a lot of people in a lot of ways for a long time. And I'm also honored to be this year a YouthBuild Teachers Fellow. There are 7 of us, and they're from across the country, and we're working really hard to put together lesson plans, lesson units, activities, videos, just things that really help teachers all across the United States in YouthBuild. Hopefully. It's a lot of hard work, and we're really trying to get it right. And probably first part of next year you'll see them. Anyway, today I'm going to be presenting a lesson, or an activity really, called Exploring Order in Mathematics. Now, this is a part of a series that was created by Ms. Connie Rivera, who's a YouthBuild teacher at Capital City YouthBuild in Hartford, Connecticut. She is also a YouthBuild Teachers Fellow. So we're really fellows. Her whole series is called Deepening the Understanding of the Order of Operations. Now, when you think of that, I don't know what you think about it. When I think of order of operations, I think of this. Oops. If I remember what this means, this is an acronym for, please excuse my dear Aunt Sally, which in turn stands for, parentheses, exponents, multiplication, division, addition, and subtraction. So, I always thought that this was written in stone. This is the way we had to do it. Well, turns out, after studying some of Connie's, and I hope she doesn't mind me calling her Connie, but after studying some of Connie's work, I found out that it's not really written in stone. And we'll see during this activity how things can be flexible. How if you stuck strictly by this, you could be wrong sometimes. So there is a definite order in mathematics, but sometimes the order doesn't matter. So it's kind of a paradox. Anyway, the first activity is exploring order in mathematics. And in just a little bit, we're going to start the class, and we're going to start it with an activity that does have nothing to do with mathematics. It has to do with life. In life, there's order in certain things. Some things order doesn't matter, and some things order does. The particular first exercise that you're going to see in a few minutes when the students come in is they're going to put a sequence of events to show how they would drive to work, how they would get ready to drive to work. What would be their sequence from the time they got up in the morning until they got in the car and went to work. Okay, you've all heard of this, I'm sure. Common Core State Standards, which are very important. This is the new rubric which we're using in classrooms now, and we have to align our lessons, our lesson plans, our units to Common Core State Standards. Ms. Rivera has definitely done this with her series here, Deepening the Understanding of the Order of Operations. What they're looking for in Common Core is deepening. Deepening is one of the major things about it. They want a deeper understanding. Another thing is much more critical thinking. Another thing is they want more of the why in mathematics, and not just mathematics, but in all subjects. More of the why and less of the how. I learned mathematics by learning how, but I didn't really learn the why. So, Common Core is one of Common Core's intent is to change that. They want to know more why instead of how. So, I think you'll see in this first lesson how Ms. Rivera starts to do that. And again, this is really the first one, exploring order in mathematics. So this isn't the whole series. We're just going to get people started thinking about algebra, about a little thinking about algebraic thinking. So, I invite you to stay tuned. In a few minutes, we'll start class. Thanks a lot. Okay, good morning. Here we are.
Good morning, Mr. Singer.
Here we are. We're going to do a little class on exploring order in mathematics. Everything has order to it, right? Does? Yeah. Everything has order. Does order matter in everything?
Yeah.
Not all the time.
Sometimes it does. Yeah. Sometimes not all the time. Okay, the first thing I want you to do is I've got a set of cards here. I want you to put them in order. They're mixed up, they're shuffled. And this is about getting to work. And there's certain steps that you have to take, and I want you to put them step 1, 2, 3, etc. Okay?
Sure.
Oh, true.
What's this, Sean?
You done? Everybody got them in order?
Yeah.
Dwayne, did you get yours? Still working.
I ain't know what you're doing.
Okay. Would anybody volunteer to read them off in order?
Ours is get work clothes on, put on shoes, unlock the car, open the car door, get in driver's seat, close car door, put the key in ignition, turn the key, put the car in gear, step on the gas pedal, and drive to work.
Does everybody agree with that? Yeah, that sounds great. That's the correct order. Could this be done in any other order?
No.
Is there anything that could be changed here?
No.
It has to be a specific order. But is there something we could add maybe to that wouldn't matter in order?
Yeah.
Can anybody think of anything that we could add to the sequence that's not here, but we could add to it that wouldn't really matter about driving to work?
Wake up.
Adjust your mirrors.
Adjust your mirrors.
Right, you put the seatbelt on.
Yeah.
Seatbelt. You can put the seatbelt on before you start the car.
I'm about to say, brush his teeth, take a shower.
Right.
Even move the housing.
So there are things that we could change that would mean that order didn't matter, right?
Mm-hmm.
But in this particular sequence, order matters.
Yeah.
We can't start the car without getting in it. Or we can, I guess, if we've got a remote, you know.
Right.
All right, okay.
The door open or put the key in.
Does order matter in mathematics? We talked about that a little bit before. When order doesn't matter. Let's look at that first. On the left-hand side there, if we got 3 times 7, that's 21, right? Well, what if we switch these and make it 7 times 3?
Still 21.
It's still 21. Doesn't matter. Does order matter here?
No.
And what? What is it? Multiplication, right?
Multiplication.
So it doesn't matter there. What about addition here? We got 3 plus 5, that's 8. What if we switch them and make it 5 plus 3? Does that change it? So it's still 8, right?
Yeah.
Right, so the order does not matter here in math, in addition, and in multiplication in this case, right? Okay. What about subtraction? We got 7 minus 5 is 2, right?
Yeah.
What if we switch them when we got 5 minus 7?
Negative.
Negative 2. So does order matter here?
Yeah.
Absolutely. You can't change the order and get the same answer, right? What about division here? 10 divided by 5 is 2, right? But what if we do 5 divided by 10? 0.5. So this definitely matters. Order definitely matters here, right?
Yeah.
All right. All right. There are names for these that we're talking a little bit later. This is called the commutative property of multiplication, commutative property of addition, and then we're going to talk about something else called distributive order of division or multiplication. Okay, look at this, the fair. Now, I don't think Mrs. Tibbs really has 5 grandsons, but we'll pretend like she does. Mrs. Tibbs is taking her children and grandchildren to the fair. Tickets cost $4 each. That's for everybody to get in, okay? She paid for 5 grandsons, 2 daughters, and herself. First of all, can you tell me how much did Mrs. Tibbs spend on her grandchildren's tickets? And can you write an equation and show her, explain how you solve the equation?
Yeah.
It's a very simple one, right? Would you put it on the board here, Carl? Yeah, on the first one, just for the grandkids.
So that's 7.
No, just the grandkids, not the 2 daughters and herself, just the grandkids. How much did she pay for just the grandkids?
5 again. So that's so that's 20.
Okay, so how did you get 20?
5 times 4, 5 goes to 4. With 5 goes to 4, that's 20. You know what I mean?
Okay, so you want to put 4 up there, right?
Yeah.
And that equals what? Because this is an equation.
20.
Very good. Doesn't everybody agree with that? That's the equation for that?
Yes.
All right. If you don't mind, Brian, just stay up there a minute, okay? How much did Miss Tibbs spend on adult tickets? Write an equation and show her, explain how you solve that equation. Now the adults are 2 daughters to herself, right? Okay, does everybody agree with that?
Yes.
That's right. Now, using the 2 equations you already wrote, Ryan, can you write a new equation that gives the total amount Ms. Tibbs paid for tickets to go to the fair?
Together?
Steady.
But I was, oh, go ahead, I'm sorry. Couldn't interrupt you because you're right. That's one way, right?
One about, let me see. Do,
Okay.
can you put it, or in parentheses, and then 5 plus 3?
You could.
Yeah, put 4 in parentheses.
Really? Like that?
And then you put 5 plus 3 next to the parentheses. Equals.
Okay, so couldn't that be done a different way as well? Can anybody think of a different way to do that?
You talking about writing it?
We can see why.
Using these 2.
That's only way I can think of is with 5 and the 3. That's I can't think of
Can't
it.
you just do it all across 5 times 4 plus 3 times 4?
Yeah, you can. Let me show you something here. if we put 5 times 4 plus 3 times 4,
You gotta do order operation. That's all it's done.
okay, do we have to do our operations if we know what we're talking about? We're talking about the fact that she spent $4 for 5 grandkids, and she spent $4 for 2 daughters and herself. So we know that this is $20, right? And this is $12, right? So 20 plus 12 is 32. Okay, just common sense tells us that, right? But if, and we have just a little bit of a change here. We're showing here, Danielle, you showed the distributive
Right.
property of division. This is how they would do it. You would go 5 times 4 is what? 20, and 4 times 3 is 12, which equals 32, right? Okay, or what else could we do?
You could just go 4 times.
5 plus 3 is 8, 8 times 4.
Yeah, 5 plus 3 is 8, times 4 is 32, right? So, does it always have to be the same order?
No.
Remember PEMDAS, please excuse my dear Aunt Sally, which a lot of people think about and they think they have to do parentheses first. Did we have to do parentheses first here? Now if we did the
No.
distributive, 4 times 5, right? And then 4 times 3, you came up with that. Distributive may be easier, just add this up, make it 8. 4 times 8 is 32. But the point is, order in math is flexible, PEMDAS, which we've all learned, I know, is not written in stone. Sometimes you can follow PEMDAS to the letter and get it wrong. And there's flexibility in it. Other times you have to make sure what you're doing. You have to go straight across, for example, with multiplication and division before you get to addition. Okay? So all we're doing, this is just kind of an introductory thing. We're talking about order in mathematics. Okay? Let's go to the next slide here. Weekend laundry. Sierra's not here. Okay, I'm doing laundry. I discover $4 in each of the 3 girls' pockets. This is somebody who has three girls and a husband. Okay. The next day, I find $5 in each of 2 different pockets in my husband's clothes. So what do we got? 3 times 4, right? $3. She finds $4 in 3 girls' pockets, and she finds $5 in 2 pockets of her husband. So we can have this: 3 times 4 plus 2 times 5, right?
Right.
Follow that equation?
How many husbands does she have?
1. But 2 different days she found $4 in his pocket, $5 in his pocket. All right. Jasmine went shopping. She bought a scarf for $15, 2 lip glosses for $7, and a cell phone case for $10. All right. How could you make an equation for that?
If you
15
put
plus
7 plus 10.
14 plus 10.
Anybody want to put it up there?
Where, John?
Huh?
Put it on the board.
On here?
Yeah.
We gotta put this dollar sign right.
You don't have to.
She got 2 lip glosses.
That's 14.
Oh, well, was it 2?
That's what it is.
Or was it 2 for 7? We don't know.
It stays $7 each.
Oh,
And what we got the phone case on there? Okay. Yeah, that's what, everybody agree that this is one way to do it?
Yeah.
okay. Yeah.
Because what did she spend altogether? 15 plus 14 plus 10,
29.
right? So it's $29. Okay.
Oh,
But we could have set it up like this.
39.
29, 39, right?
Right.
We could have set it up like this. 15 plus
2 times
2
7
times 7
plus 10.
plus 10 equals 39, right?
Yeah.
But this worked, didn't it?
Mm-hmm.
So, did order matter here?
Yeah.
No.
No.
You do it two different ways, could you? How could you change this to where order didn't matter at all? You could change the whole problem to where order didn't matter at all.
Just flip it.
Hmm?
Flip. I mean, yeah, flip the top. Like how you write the equations, if you write the same numbers down, but in a different format, and it'll still be the same answer.
Yeah, but how can we change the order so that we don't, the order doesn't matter here? We have to go 2 times 7, we can't go 15 plus 2 plus 7, right?
Mm-hmm.
We could do it like this, we go 15 plus 7 plus 7 plus 10, couldn't we?
Right.
Or, we could change the scenario and say she just bought 1 lip gloss instead of 2. Then it would be 15 plus 7 plus 10. Yeah, she bought 2. Change to see when order doesn't matter. Does order matter here now?
No.
Still $39, right? No,
that
now it's
one
32.
See, you only do the same thing you do.
32. Well, I can't agree with you sometimes. Okay, so let's go to the next one. When does order matter? When doesn't order matter? Let's see what we got here. Buffet. We're going to skip the buffet.
Let's do the buffet.
You want to do the buffet?
Yeah.
All right, we can do the buffet.
I'm not
It look like okay though.
Okay, can somebody read this for me?
Our food is $7 per pound.
$7.
$7 per pound, and salads are $4.50 per pound. You buy 5 pounds of hot food, 2 pounds from the salad bar. 3 waters at $1 each.
Anybody care to put that in the equation? Anybody? Anybody?
Go ahead.
Volunteer?
Janae.
Why you won't put on that? I can read stupid.
You
Janae, you're good at it.
You are stupid. You need to put up a
5 times 7 plus 2 times 450 plus 3. You can always do it more than math. You buy 5 pounds of hot food, that's $7 per pound. Yeah, plus 2 times 450. Slide on this
Is that 42?
Huh?
Is that 42?
47.
It's 48, man.
This is what he said.
47,
So you're talking about me. Now, okay, that is the correct answer. That's very good. The only problem I have with it is if I didn't know about order in mathematics and I didn't know what this problem was about, somebody just put this formula on the board, maybe I would do this. I would say 7 times 5 is 35. And then I would say 2, okay, there's no more. So I would do multiplication first using PEMDAS. I would say 7 times 5 is 35 plus 450, so that's 3950 times 2. 3950 times 2 is going to be $79, I think. Plus 3, I get $81. Times 1. Yeah, if you got the information, it makes perfect sense, right? But what would be, let me see this one.
If you don't got the information, don't you just have to solve the problem?
If you haven't got the information, you wouldn't want to do this. This is a case where you need parentheses, so you know what to do first. Right? Here we have to have order. Order counts here. Sometimes it doesn't count. The way you did it didn't count as long as you know what the scenario is. But if you got a problem, just a problem like this, you could get it wrong unless you knew what was what. It sets it apart and makes it. Remember, PEMDAS, please excuse my dear Aunt Sally. In this case, you would do parentheses first. P stands for parentheses, right? Okay, good. Thank you very much. So, just like you put up there. Second to the last, I think this one is. New car price. Calculator's expensive, right?
I got a pencil.
Take a look at this scenario here. You're buying a new car and it's $21,000. All right, the sales tax is 6%. The dealer rebate is $1,000. In the end, how much do you pay for your new car? Anybody figure that?
Are we gonna set that up?
21,000 times .06.
Okay.
Divide that 1,000.
Times .06. Get that answer and subtract $1,000. 0, 0, 0, 6, 12.
So what do we got? $1,260, right? We got 21,000 plus 1,260. 22,260 minus 1,000 is 21,260, right?
Yeah.
Okay. Does order matter here?
Yeah.
Yeah.
What if, when you go to the DMV, what do you pay sales tax on?
The total price of the car.
Total price of the car, is that before the sales tax or after the sales tax?
That's before.
Okay. So you wouldn't really spend $21,260 for the car? What if you took $1,000 off first and then took 6%? Would that change the answer?
Yeah.
So order matters here, right?
Yeah.
Right. Instead of doing the math, everybody sees that order matters, right?
Yeah.
Okay. Here's one last one. I think this is the last one. Payroll costs. You're running a company. You got 5 employees who make $12 an hour and they work 45 hours. You got 2 employees who work 40 hours at $15 an hour, and 1 employee who worked 40 hours and he makes $27.50 an hour. It must be amazing. Right? Yeah. Does order matter here? How would you figure this out?
What you trying to figure out? How much they make?
Total payroll. You're the payroll guy.
I don't think it does.
So you want to know who got the difference?
No, I want to know
How much
what
you
it
got?
cost you for that week in payroll.
I don't think
That's
it
a week's worth of payroll.
So you will have to multiply the hours by the rate of pay times the amount of employees, then add them all together.
You want to do the
And
employees
then-
times hour, get that total number in times the rate of pay?
And then you got to do overtime. 'Cause that's what.
Right.
No, sure.
On me, that is.
What do you see overtime at?
41. So once you go over 40 hours, that's overtime.
But you still would do the employees times
But if
the
you
hours,
get
get
that
that total
salary,
in times
that's
the
no
rate of pay.
Yeah, they're not considering overtime here.
Right, that's what
I
I'm
was
saying.
just saying.
Information given, honey.
So, Danielle, you're saying that you would look like 5 times 45 times 12?
No, 45 times the rate of pay times the employees.
Would it matter?
No,
think
really,
it
I don't
would.
think it would. Cause she's saying a different way.
Because you
I'm saying
still
a different way.
using
I think you would get
multiplication.
the- Yeah.
All the way
Multiplication
across,
is-
and then you use an addition to get the total.
Multiplication is commutative.
Right,
So you can switch these around any way you want. You
right.
can go 40 times 5 times 12, or 12 times 45 times 5, or any way you want. What you couldn't do is add 5, 6, 7, 8 employees and multiply it by something, right?
Right.
You have to stay in your line here.
Different rate of
So
pay.
order doesn't matter that way, but it doesn't matter this way,
Straight across.
right?
Right.
Okay. All right. So does order matter in mathematics?
Yes.
Always.
Nope.
Sometimes.
Sometimes, right. Let me just show you real quick, and we'll be finished.
I thought y'all was going to do that problem. Why y'all talking about this?
No problem.
He just want to know how to figure it out.
The payroll. Y'all ain't going to do it.
This one?
Good.
Yeah, y'all know how to solve that problem.
Go ahead. Now you can tell us the answer. You really need it.
That's 40 pants, dude.
Who's smarty pants?
You man.
All right. Here's what one thing I want you to get out of it. These are 3 properties of mathematics. Okay? In addition, we talked about 7 times 3, and we talked about 3 times 7. They both equal 21. Remember we talked about that? All right. This is commutative. And how do I remember that? How do I remember that being a guy that needs acronyms and sometimes takes you a while for things to soak through? 7 commuted over here and 3 commuted over here, right? Commute to go to work. Right, that's how I remember that. All right. Also, what's the other property that's got commutative property? What's the other function?
Addition.
Addition. Right. So this is multiplication. So using the same numbers. Whoops. We get the same answer? 10. Right. So addition is commutative, right? What's associative? Anybody know? Associative just means, for example, in addition, let's add another number here, plus 3. 7 plus 3 plus 3 equals what?
13.
Okay. What if we added these 2 together, made it 10, and we added 3? Would that change the problem?
No.
Still 13, isn't it?
Yeah.
What if we added the 2 3s together, we added 6, and left this at 7? So would this change the problem?
No.
Still 13.
13.
So what happens here? Associative, again, memory trick. The 3 associated with the 3 here, right?
Right.
And became 6. And 7 associated with the 3 here became 10, right? So that's associative. Distributive. Distributive. Talking about division here. Let me give you a good example. What is this example? What's the answer to this?
25.
You're right. Now, what if we did this? Right. If we go 2 times 5 is 10. 5 times 3 is 15. Equals 25, right? So we've distributed things. It's a little bit harder for me to grasp as far as a memory trick. But you might say, this is pretty primary, pretty basic. And why does this matter? What this is preparing students for higher order thinking in algebra. Because when you get into higher level algebra, you gotta have to know how to switch these things around like this in formulas. You need to know about associative and distributive and commutative. And this is just the basic start of it right here. If you just know this little thing here, it'll help you solve a lot of algebra problems later.
Right.
Okay, thanks a lot. You have a great class.